So I'm going to do an example here. Maybe I'll use mesh or nodal analysis using the S domain. But this is what you have to remember. I try to summarize the previous video. If you have a resistor in time domain, when you go to S domain or frequency domain, which is Laplace, the resistor stays the same. The value of R is the same. If you're looking for the Y value, that's the Z value here. If you're looking for the Y, Y is over 1 over Z, so 1 over R. If you have an inductor, the Z value for the inductor, you replace the inductor with SL and a voltage source of negative on the top, positive on the bottom, L times I sub 0 minus. If you're looking for the current, if you want to break it down in terms of current, there is the expression for it. So you have two sources, the Y value for that 1 over SL and a current source pointing down I of 0 minus over S. If you have a capacitor, the voltage, it's 1 over SC times I sub S plus this one. So you replace this with 1 over SC, that's the Z value. So notice the voltage here is going to be this current times the Z value. When you multiply this times I sub S, you end up with this piece, plus the voltage drop here, which is V sub 0 minus over S. If you're looking for the current, you're subtracting here, so this is plus to minus, the current's coming down here, and that's a minus pointing upward. So the value of this current, the Y value, is SC, and this will be C times V sub 0. So let's take an example and see how we're going to do that. Just remember this, and I'll keep coming back to this. Here's my first example. Let's say we have a voltage source here. We'll do something we didn't use before yet. And it's 4 e to the negative 2t u sub t. Again, what that means, this source has a value of 0 for t less than 0, and 4 e to the negative 2t for t greater than 0. This is 1/3 F farad. This is a 10 ohm resistor. This is a 4 Henry inductor. What else we got? We got minus to plus. And this is 2 e to the negative t u sub t. Again, this source was dead for t less than 0. Both of these sources were off for t less than 0. So if I do, this is I sub 1, and this is I sub 2 as a function of time. So first thing first, let's look at the circuit for t less than 0. This source was out. That source was out. So we had no source. This has a value of 0. So your circuit really looked something like this. Voltage source always short circuit. Current source always open circuit to make it 0. So if we look at that, what was the current going through that inductor at 0 minus? What was I sub L at 0 minus? And what was the voltage drop right here? We'll call it VC at 0 minus. Since you had no source in the circuit, VC at 0 minus is equal to 0. Current through the inductor at 0 minus is equal to 0. Why do I need them? Let's go right here. Remember, we have to replace the inductor with this equivalent circuit. We have to replace the capacitor with this equivalent circuit. So we need to know what the voltage across the capacitor is 0 minus. We need to know what the current through the inductor is 0 minus. Either one of these, I need to know what the current through the inductor is 0 minus. I need to know what the voltage across the capacitor is 0 minus. Okay, so let's change the circuit from time domain to Laplace. So as I said before, I threw the notes from before away. I said basically you have a smart neighbor, you want to solve a problem, so you want to change it to their language so they can solve it for you and change it back so you and I can understand it back to English. Well, this is the same thing, the circuit and time domain. So let's convert that to Laplace. Oh, this marker is dying, so let me throw it away. Good. To Laplace. The Laplace of e to the negative 2t, that's 4 over s plus 2 now the Laplace, here we go, of the capacitor. I'm going to replace the capacitor with 1 over SC. 1 over SC. If you do the math there, this capacitor will have a Z value of 3 over S. The resistor doesn't change, still 10. Notice I didn't have to deal with this value because that's a 0. Let's look at the inductor now. The inductor will have a Z value. The Z value for the inductor is what? S times L, and the initial condition was 0, so this is gone. So that's SL, which is 4S. And this is 2 over S plus 1. This is I sub 1 here as a function of S now because we're in Laplace now. And this is I sub 2 as a function of S. So this is the Z value. You treat each one just like a resistor. So if we do a KVL in this loop, right, we'll call it loop 1. That's this one. 1 here, 2 here. If we do KVL for loop 1, what do we have? We have 4 over S plus 2 is equal to this source minus the plus becomes a minus. Move it to this side. That's a plus. This Z value times I, 3 over S times I sub 1 plus 10 times, what's the current coming down? I sub 1 minus I sub 2. If you clean this equation, we will have 3 over S plus 10 times I sub 1 as a function of S minus 10 I sub 2 as a function of S equals 4 over S plus 2. That's equation number 1. Let's do KVL at 2. This guy right there. The voltage drop here. Well, let's put the source. Well, I'll do it. 4S times I sub 2 minus 2 over S plus 1 plus 10 times I sub 2 as a function of S minus I sub 1 as a function of S equals 0. So I'm going this way. If you clean that equation, what do we have? Negative 10 I sub 1 as a function of S. And what do we have? We have plus 4S plus 10 times I sub 2 as a function of s equals 2 over s plus 1. So there's my two equations. This is equation number 1. This is equation number 2. Go to your calculator. If you have a TI-89, plug them in. And here's what I have for I sub 1 and I sub 2. 2s times 4s squared plus 19s plus 20 over Yowza 20 s to the fourth plus 66 s cubed plus 73 s squared plus 57s plus 30. I didn't say this method's easier. I know this works all the time. I sub 2 30 s squared plus 43s plus 6 over s plus 2 times 20s cubed plus 26s squared plus 21s plus 15. And now you're just going to take the inverse of that. And if you're lucky, you have access to Mathematica, because otherwise we'll be there for another 45 minutes. And you know we can't make these videos more than 15 minutes long. So back to time domain now, and I'm going to cheat and use Mathematica. So I sub 1 as a function of time is equal to negative 96.4 e to the negative 2t minus roughly 345 e to the minus t plus 841, and there's some decimal portion, I'm not just putting them there, e to the negative 0.15 t times cosine 0.85 t plus 198 roughly e to the negative 0.15 t sine 0.85 t. If I didn't have Mathematica, I would have been here for another, at least, honestly, probably an hour plus, and still get it wrong. And what's I sub 2 as a function of time? It's going to be roughly 482 e to the minus 2t minus 241 e to the minus t plus 723 e to the minus 0.15 t cosine 0.85 t plus 473 e to the negative 0.15 t sine 0.85 t. Now, if you have a TI-89, you might be able to do the inverse Laplace of that on it too. Now I'll stop with this video. Maybe the next example I'll pick a reasonable problem.